Hello everyone. Great thing comes out of patience. So keep calm and have patience. With this theme, I welcome you all to our AJ Learning channel. My name is Amit Jain and finally our wait is over now. We have started the first step of Odyssey to learn EMT. So in this particular tutorial, we are going to find the answer of four basic things. What, where, why and how. Without wasting your precious time, let's get started. Now here is your first question. What is a field? A field is a function which specifies a quantity everywhere in a region. For example, temperature distribution in a building, sound intensity in a theater, or the gravitation force by earth over a body, velocity of raindrops in the atmosphere. So I can say field is simply a function which specifies a quantity everywhere within its region. The quantity may be scalar or vector or tensor. We will learn later on what is a scalar, vector or tensor. But right now you need to understand what is a field. So field is a function which specifies a quantity everywhere in a region. So now the second terms come. What is electric field? So as I have said earlier, field is a function. So electric field is a function of charge which specify its quantity or its effect everywhere in its region. The same with what is magnetic field? So magnetic field is a function of moving charges which specify its effect everywhere in its region. What is lumped and distributed elements? So the term is lumped. Lump is that type of circuit in which elements size is much more smaller to the wavelength of the applied voltage and current. Or simply I can say they mainly represented with the help of differential equation. Or in other words I can say they concentrated at a single point. They basically represent in terms of time, say for example resistor, capacitor, inductor, or you have studied the lumped elements in circuit analysis. These are called lumped elements. And what is distributed elements? As its name says, distributed elements are those elements whose circuit size or whose size is comparable to the wavelength of the applied voltage and current. And where you find the application of distributed elements? The distributed elements find the application in terms of electromagnetic wave. So when charge is depend only on like space parameter, then it is known as static, and that field is known as electrostatic. And when magnetic field, or you can see the current which is flowing is constant with respect to time, then it is known as magnetostatic. And for these two fields we required an element which is known as lumped. And when these two field parameters varies with respect to time as well as space, then it is known as time varying field. And for that we require an element which is known as distributed elements. So I hope it is clear to you that what is field, what is electric field and what is magnetic field. In this particular course we will deal both type of element, lumped as well as distributive. Now combine both the definition and try to understand the definition for electromagnetic field. So electromagnetic field is a branch of physics in which we deals with the phenomena of electrical as well as magnetic in static or in time varying nature. Now let's talk about the content of the course. What we are going to learn in this course. So, simply I divided the field in two parts, static as well as dynamic. Now first understand what is static. Static field is that field which does not vary with respect to time. And this type of field originates two field, electric field as well as magnetic field. And this electric field is known as electrostatic and this magnetic field is known as magnetostatic. So the term must be clear now. What is electrostatic? Electrostatic is that type of field which does not depend upon time or which does not vary with respect to time. Same, magnetostatic is that type of field which does not vary with respect to time. And these field depends only on spatial parameters, like space parameters. If we are representing these field in terms of rectangular coordinates, the parameter may be x, y, z. Or if we are representing this field in terms of cylindrical coordinates, then the parameter changes like rho, phi or z. And the most important thing is that in the static field, electric field is independent of magnetic field. Now moving towards the next part, which is known as dynamic. So dynamic field are those field which varies with respect to time. It means it is a form of a wave, and this field generates a wave which is known as electromagnetic wave. Electromagnetic wave depends upon time as well as spatial parameters, and the field produced by dynamic is known as electromagnetic field because it is the responsible field for the generation of electromagnetic wave. Or you can say that electric field and magnetic field both are dependent on each other. And you find the application of dynamic field in various subjects like transmission line, waveguides, antenna designing, and so on. We will see it later on. So I hope the course content is clear to you. We are going to understand this content in 8 units. The first unit we start with the vector algebra. In second unit we will start with the static field, and which is basically for electric field, that is electrostatic. Third unit we will deal with static field again, and that is for magnetostatic. Fourth unit we will take the time varying field, in which we study the Maxwell equations. Fifth unit we will see the advanced topic of electromagnetic field like EMI, EMC, and what is EMI and EMC I will explain you at that time. In sixth unit we will discuss transmission line. In seventh unit we will discuss waveguide, or in eighth unit we will discuss antenna designing. I hope the course content is clear to you. The most important thing to understand the EMFT in a very simple manner, you require a tool. And what type of tool you require for this course? We require a knowledge of vector algebra and the application of Dale operator like gradient, divergence, curl. These are the applications of Dale operator, are also known as nebula. These two tools are very helpful to understand or very helpful to represent a charge or a current in various densities. So in the first unit we will deal with this part only, vector algebra and applications of Dale operator. And the second tool we are going to use to understand the EMFT is MATLAB. We will see different numerical analysis through MATLAB. After static field, it means we are going to see the numerical analysis through MATLAB in time varying field. Or in transmission line, we will see the application of Smith chart. So these are the tools you require to understand this course. Now the most important question. where you find the application of EMT. Yes, of course, you find the application of EMT in electric machines in terms of transformer, in terms of motors, in terms of relays. So these are the application of electromagnetic field in electric machines. And there are many more. You find the application of electromagnetic wave in antenna or antenna designing, because as its name says, antenna is a device which convert the electric current into electromagnetic wave. At the same, it also convert the electromagnetic wave into electrical current. In satellite communication, you will find the application of EMT. In bioelectromagnetics, say for example MRI, magnetic resonance imaging, or ECG, electrocardiography, and there are many more examples. In fiber optics communication, you will find the use of Maxwell equations. In EMI and EMC, as I said earlier, electromagnetic interference and electromagnetic compatibility, these are very important topics. We will discuss these topics separately in Unit 5. In electromagnetic energy conversion, you will find the application of EMT, or simply I can say in radar designing, radio detection and ranging, and many more. You will find the application of EMT in more than 180 fields. I have mentioned only few fields here. So you can decide by yourself that this course is very basic for your many types of electrical as well as electronics field. Now the most important question. Why? Why should you learn this type of course? What is the importance for you? As I said, there are many fields where you find the application of EMT. You will be surprised to get this information that most of the papers published in the research area of EMT. Say for example, if 100 papers are published, then out of, let's say, 60 papers out of 100 papers are totally published over EMT, in the areas of EMT. So it is a very good area, and regarding research, you will find the question from EMT, antenna, waveguides, transmission line in GATE, in public sector undertaking, in engineering, Indian engineering services. If you take electrical engineering as your optional, you will find the question of electromagnetic field theory in IAS also, in national eligibility test. If you did post graduation in physics, you will find the question based on EMT in your NET examination also, and you will find it also comes in the class 12th in physics. So you will find a question based from EMT in IIT also. In so many graduation courses, you will find physics as your one of the subject. Like say for example, BSc in physics or BCA. In first you will find physics, and your simply the last target, which is your university exam. So I hope this is a very important subject. Don't take this subject as lightly. I will try to explain each and everything in a simpler manner. Now, next question arises, how we are going to learn. For that, you require some references, some books. So I personally suggest you take a book of Principle of Electromagnetics. Either you can take 5th edition or 6th edition, but the name of the author is Matthew N. Sedicu. Remember this, Matthew Sedicu or Sedicu. And the publication is simple, Oxford Higher Education. You can take this book as your reference book. The second book I may prefer is Engineering Electromagnetics, and you just take the 7th edition. and very well known name author is William H. Hare, John A. Buck, and the publication is McGraw-Hill. And apart, you can take any one book. So better if you take SEDQ. And apart from that book, you need to learn all the things from our tutorial, because from the next video, we are going to start our tutorial on whiteboard, or I can say in a classroom mode. Now, what is the duration of this course? So we have started from today, 23rd of January, and we will try to complete this course before mid-April or up to 16th or 17th April. And as I had said earlier, there are 8 units. So this is all for this video. I hope you are able to find the answers of what, where, why, and how. If you like the video, please do subscribe and press the like button. And please share this video, this tutorial with your friends. And in the next video, we are going to start our first unit, basics of vector algebra. And this video might goes up to 30 minutes. So have some patience and remember one thing, do not give up, because beginning is always be the hardest. You need to have some patience and trust me, I am doing my level best. Thank you very much. Take care.